Hello guys, welcome to Inside Electronics. So in today's episode, let's take a look at this PEPSI can shaped multimedia speakers. Now this portable speaker is not just a portable speaker, it has a built-in audio MP3 decoder. It has a USB option. It will has multiple input options like this USB right here. Has a charge indicator. It's a dual color LED over there. Switch turned on, and this thing has a headphone out. In the world of 2017, a headset port on a cheap device, that's really cool. And a mini USB plus an auxiliary input. Now this thing uses the data pins of a USB cable as audio input source, and which I have explained in another video I believe. And it has a micro SD card slot, a switch which has a press action and forward and backward to select the volume, the menu, play, pause. This switch has multi-functions built into it. So the first thing I want to let you know that this thing is no longer working. If I turn it on, all it does is just blinks the LED. If I just turn the light off, as you can see, really makes a pretty good illumination out here. So if I the really interesting thing I want to show you guys is how much power do you think this thing consumes when this thing is in operation. Let's be really optimistic and say 1 amps. Okay, that's when you are really generous and we are really optimistic. I haven't measured it yet, how much current exactly is in drawing, because this thing is not working at the moment. But let me show you something really interesting. I have a 5-volt power supply. It's a 1.5 amps power supply connected, and I want you to keep an eye on this display. Okay, keeping it close so that you can see it. I'm just turn this thing off for better contrast. I believe that's visible. So keep an eye on the meter. Okay, I'm going to plug it in. Oops. As you have seen, this thing took around 5 point something amps of current. That is ridiculous, because 5 point something amps for this thing, that clearly indicates something is wrong with the circuit board, and that's exactly why this thing is not working. So let's open it and see what's inside. And by the way, if you take a look, you can see a 32.768 kilohertz clock crystal over here. Has only one screw, keep holding everything. That's a crystal over there. Okay, the circuit board is really easy to take out. How does this part comes? Let's twist it. Oh, there it is. There are 2 more screws that I need to unscrew. So once that is unscrewed, I think the whole thing will come apart. Oops, there goes the screws. Let's keep them inside. Oh, bits are falling away everywhere. So this thing, I think, is what used to hold. Okay, there is a latch mechanism. As you can see, there's a catch over here which stops this thing from going to beyond that point, I believe. Yeah, exactly, it can only go up to that point. So that is what used to keep the battery and other things in place. Let's take this to bits right now. I hope you are in focus. Let's take a look at the battery. I just want to know how much is the capacity of that cell right there is. So let's unscrew it. Okay, that's it. Okay, there it comes. That's the other piece coming out. And this is actually a usual 4 ohms. Yeah, there it is, a 4 ohms 3-watt speaker, and there is nothing written on the battery at all. Let's peel off this thing right here. Oh, it's not going to reveal anything. In fact, okay, there's a date code at least. It's a 4th of 2013. So this thing is 4 years old right now. So let's take the whole thing out completely. Yes, there it is. So this is the actual circuit. Let me bring the zoom down so that you can see better. So these are all the wires that are going inside. Let me turn this on, and it is no longer showing the LED. I don't know why it is not turning on the LED. Maybe I broke some wires, I don't know. Anyways, let's just take a look at what's actual stuff. So these are the three main chips on the circuit board, and there is an antenna, FM antenna, and because of the close proximity of that antenna to this chip over here, I assume that this is an FM decoder chip right here. And when you look at it, you can actually see. Let me tell you that. See that? Did you see that? By just looking at that, you can actually tell which pin goes where, because it's only a single-sided board. It is really easy to reverse engineer this thing, but it will take a hell lot of time, in fact. So this chip has to be an MP3 decoder because of all the pins going to it from the different points. Let me turn this on. So it has to be microcontroller, and also because of the proximity of this crystal, I assume this has to be microcontroller right there. This has to be microcontroller right there. And the speakers are these purple wires, and they are connected to this thing, so it has to be an amplifier. Anyways, I'm going to pause for now, and I will be back once I sort out which IC is what. I'll be back. So guys, I looked up the internet and found the datasheet for most of the components except this one over here, this central chip, which has to be a microcontroller because there is a custom microcontroller, because there is no information available with these numbers. But that has to be an MP3 decoder because every input is connected to it. Even if it's the USB, the auxiliary, and the micro SD, everything is connected straight to this first. And the next chip, this one right here, is an RDA5807, which is a universal FM demodulator IC. And surprisingly, this thing has a lot of features packed in a really small size. This has 50 to 108 megahertz support, which makes it pretty much universal. Normally in these days everybody is using the 88 to 108 megahertz band, but still there are some places where they use the OIRT bands, which is the 65 to 75 megahertz, I think, and also the Japanese bands, they are 76 to 95 megahertz, and this chip can cover everything, so that makes it pretty universal. And it's operating on a low voltage of 2.7 to 3.3 volts, has bass boost built in. And the good thing about this is, if you take this out and make a separate circuit out of it, you can directly connect 32 ohms speakers, which are basically headphones, straight to it. It does not need any additional amplifiers for that. And it has RDS, RBBS capabilities, and a lot of features packed into this tiny little package over here. But in this case, the output from the chip, this FM demodulator chip, is connected to the input of the audio amp, and at the same time this one also is connected to the audio amplifier. And by default the microcontroller selects the radio as the source if there is nothing present in the USB or line in or the memory card. That's possible because this chip has an enable pin that can be used to enable the chip externally, and the controller uses that for controlling the entire circuit. And it has to scan through all these inputs, the USB, the everything has to scan through all of this, because whenever you connect a new thing that has music in it, it actually stops the FM and switch back to whatever the input really is. And also it has to make selections according to the mode selection button, which is this one right here. And moving on, this chip over here, you can actually expect it is to be an audio amplifier, and that is the LM4871 LD version of it, which is a 3-watt mono amplifier. The LD stands for low dissipation, and it is used with 4 ohms 3 watts load, and just the 4871 is used for the 8 ohms load. And the things right here is the chip. This chip needs 3.3 volts to be functioning, and that is derived straight from the battery. The battery terminals are connected in parallel to it, and also there is a resistor in series somewhere. When I measured it, I'm getting a resistance that indicates it is using a resistive drop method to reduce the power if it is being powered from the USB. And also the headphone is something really interesting because the mono output is split using these resistors, and it is then connected, the resistors are then connected to the left and right pairs. So if essentially you are getting the same channel on both the left and right on your headphones. The LED is just really simple. All it does is the ground pin is connected straight to the ground, and the switch, and when the switch turns on this point, it is getting 3.3 volts, and that is connected to this chip right here. So it is getting the power from there, and that's pretty much it. So really simple circuit, but it is a really bad design. I mean, it is really cheap. And I also tested, because there is no battery protection circuit in it, I also tested the battery, and I found that it has a built-in battery protection circuit inside, which is really a good thing, you know. And also I take the time to measure the capacity, and it turns out to be 160 milliamps capacity. So basically speaking, that's pretty much it. That's all about the cheap little component right here. And one last thing is this little LED over here. If you apply a 5-volt power supply, if you connect a 5-volt power supply, then the red LED lights up, and what happens is that the other LED, the green LED, is the status indicator for the microcontroller. So they're using a single LED for both the charge state and the state of the microcontroller indicator. So I think that wraps it up. That's it for the Pepsi can speakers. So I have done reviews about other speakers. You can watch them one by one up by clicking the I button up there. So anyways, that's it.